All right, if you're online, we'll get started in about a minute here.
No, they're just picking up the
Online folks will get started here in just a minute. I just want to make sure you guys can still hear me. If somebody could post in the chat, please.
Good
to go on.
Still here? All right.
Where the building is, man, it's
It's that velocity.
Where it is in Madison?
For AC, high velocity.
All right, everybody made it back from lunch for the most part? Sounds good. Interesting. Like I said, it's been about a year and a half now of doing these, and I've learned if you can't control your lunch, you have to wear a dark colored shirt when you go to lunch. I wore this one once and I went into a lunch and learned, and they're like, yeah, we're having spaghetti today. And I'm like, oh, crap, this isn't gonna work. So now I know, but like today I can control what I'm eating. So I got something with, it was all white sauce on a burrito down at Chipotle there. So you guys can't tell dribbled or not. All right. So mass timber stuff. Yeah, like I said, we'll wrap up with this probably in the next half hour or so. There's just a couple things on the fire stuff that I want to touch on, and I'll try, if you guys don't mind, I'll keep going a little bit and just give you a real quick overview on some of the acoustics and energy and some of that type of stuff, just to kind of round out the presentation. I have a 3-hour version and a 4-hour version. The 3-hour version kind of stops at at the end of this fire stuff, but we'll take just, maybe 5-10 minutes or so, go through some of that other stuff too, just so you guys kind of see what's in there a little bit. And then we'll jump over to some shear wall stuff. And then actually in between, I'll show you guys some of the stuff that's on our website, just so you guys know what resources are out there and what's available to you guys. So that's sort of the plan here for the afternoon, and then wrap up it's around 3:30, somewhere in there. So. Ooh.
Jump back over to this.
All right. I guess before I get jumping into here, any questions and anything from the morning stuff, any lingering stuff that you guys thought of after lunch or during lunch? All right. All right. So again, we already talked about some of the fire resistance ratings. We talked about where those numbers all came from. Again, non-combustible does not mean fire resistant. The taller or the bigger pieces of wood, essentially, they do have, some fire resistant capabilities to them, right? They're going to resist fire because they're going to char on the outside. That's going to protect that inner core of the wood, but that doesn't mean it's not combustible. It's still a combustible product. So if you do get any code requirements in there that say, you can't use a combustible product, mass timber is still a combustible product. And just like that, so mass timber, it has some inherent fire resistance just because of the dimensions of it, because it has that larger size to it. We already talked about some of this stuff and the protection that's required. So I'll jump through this. Again, anytime that you're calculating any type of fire resistance of a wall or a beam or column or anything like that, it's got to follow something here in 70322, right? And that's where we get the fire resistance rating, that non-combustible rating. It's in 722. So it's listed out here as one of your options to determining a fire resistance rating of an element. Fire resistance design. So AWC, again, 722, that has some of that stuff in there. The NDS in chapter 16 talks about fire resistance of wood members. And then the American Wood Council, we put out TR10, or technical report number 10. And that's a report on calculating fire resistance of exposed wood members. Again, that's, I don't know if I mentioned this, I know I mentioned our website a couple times. All of our documents, they're out there, they're free. So if you guys ever want to see any of this stuff, it's all free out there on our website. And actually, I forgot that too. As I've been going through here, I don't know if anybody noticed, there's a little logo down here in the corner. I'm not a salesman, I always forget this stuff, but that refers to this book, Mass Timber and Buildings in the AWC. This is a book that American Wood Council and ICC put out together based off the 2021 code. it's, I want to say 30-40 bucks, something like that out there on the website. If you do get any, mass timber buildings that are coming into your jurisdiction, anything like that. This is actually a copy I bought when I was still at West Dallas, because we had a mass timber building that was coming in. So I kind of bought this book, before I started with AWC, but I'll pass this around, you guys can kind of flip through there, see what's in there, because, I'm not gonna tell you to go buy a book if you guys don't have a clue what's in there, so. I'll pass this around, but again, this is the copy I bought in West Dallas, so if I can get that back, and I'm sure they'd buy me a new one, but got some nostalgic value to it. But anyway, if you want to learn more, a lot of the graphics that are in this are taken from that book. Again, it's based off the 2021 code. We're developing what will probably just be like an insert that we can just kind of slide into the back for free for the 2024 codes. Since there wasn't a lot of mass timber changes in the 2024, so that's what they're doing. So if you buy a version of it now and you're like, should I wait? Should I buy this version or should I wait till the 2024 version comes out? That's the direction that they think that they're going to go. That ICC thinks that they're going to go with this is just to come up with like a little supplement that you can stick into the back of a dozen pages or so. But anyway, so that book's not free on our website because that's joint published with ICC. But the rest of them, NDS and TR10 and all those other ones, you can get all that stuff on our website. And like I said, if we get some time today, I'll show you guys where a lot of that stuff lives. TR10, again, it's a technical report that talks about all the inherent fire properties of exposed wood. We actually just wrote the FDS, the fire design specification, which is, if you're familiar with the NDS, it kind of follows that same flow and that same look to it. So that's the fire design specification. It's not, adopted by the AWC yet. Not even in the 2024. We just finished it up, the latest version, so we're going to try to get it into the 2027. ICCES is evaluating it right now to see if they can use that for some of their evaluation services and use that as a standard for themselves. So, and I think, NFPA 5000 that didn't get into that. So, but either way, the FDS you might start to see that coming up. In future code versions, but again, so those are some of the things of where a lot of this stuff comes from, right? It's out there. It's on how to calculate your fire resistance of wood. So in the NDS section 16 or chapter 16, you can do fire design up to 2 hours. Just about any elements out there, and then those different products. So sawn lumber, glue lambs. And then your structural composite lumbers. And then the technical report 10 TR10, that's going to cover CLT and a bunch of other generic wood members like that. So I've talked about a few times how that wood's going to char. It's going to protect that inner layer of the wood, right? And that inner core. This is kind of what that looks like. If you take this was a column that was they did a fire test on it, cut it down the middle, and that's kind of what that looks like. So you can see that char on all 4 sides, but then you can see that inner core of that wood. It stays dimensionally stable. It stays relatively cool, and it doesn't lose its strength, right? That's why wood actually performs a lot better than steel in a fire, right? Steel is going to melt and start to bend and deform. Wood is going to char and pretty much stay dimensionally stable other than that. So here's, if you have a beam that's right up against your ceiling, this is pretty much what that's going to look like. So when specifying these beams out there, they're going to specify it with the capital B and the capital D, your width and your depth. That's the actual beam that they're going to put into there. But when they're running through their structural calculations, they're going to use this lowercase b and this lowercase d, just the dimensions of that inner core, because that's what's going to be left after the fire. You'll notice on a beam, if you're tight up against there, you're not going to get any fire up top there. But if you do have a column, now you're going to get fire coming in from all 4 sides. So again, that lowercase d is your depth on that is going to be a little bit smaller. So how much char is there? This is a table out of the NDS. So if you need a 1 hour fire resistance rating on a piece of wood, right? If you need a 1 hour, that actual char depth is typically measured to 1.5 inches. That's what they're going into the code with. But when you're designing that, you're going to use the effective char depth of 1.8 inches. Gives you that little bit of safety factor in there, 20% safety factor. If you need for example, a 2 hour rated column or beam or wood element, now you're looking at an effective depth of 3.2 inches. So if you're thinking about that column, now where you've got char coming in from both directions, you're gonna have to do that about 6.5 inches larger than what you actually need. So if you need a 12 by 12 column, we'll say for structural integrity, that's what you need to hold up this building is 12 inches by 12 inches. And you want that column to be 2 hour rated. Well, now you're adding 6.5 inches onto that. So now you've got basically an 18.5 by 18.5 column. Because in each direction, 3.2 inches is going to burn off, and you need to leave that 12 inches by 12 inches at the end. Make sense? All right. About that. All right. So CLT, similar, but a little bit different. A little bit different values on it. And that's because every time that it does burn through a layer, one of those laminations, it does, the fire, they tested it, it does pick up a little bit more energy, I guess, as they go through. So you'll notice down here, if you're making CLT out of 1-bys, which you can do, and you've got 3/4 inch boards on there, now you're at 2.2 inches of effective char, right? We were at 1.8 before, which, comes in, what you would have with a typical 2-by. So if you're using typical 2-bys, you're still at that 1.8. If you have smaller members, you're going to have to do a little bit more char, and same thing if you go down to the 2 hour. You're at 3.2 before. Now we're looking at 3.6 in a CLT situation. And so here's just a quick example of that. So if you assume a 5-layer CLT with 1.5 inches, and you need that to be a 1 hour rated or 1 hour fire resistance rating to it, you've got that 1.8 inches of char based off of here. So 1 hour, 1.5 inches, 1.8 inches of char. So, that 5-layer CLT is going to be 7.5 inches. Subtract off that 1.8 inches, and you basically have a 5.7 inch CLT that's going to, support all your structural loads. So hopefully that's adequate. If not, then obviously you got to go to another layer to that. All right. And I want to say that kind of wraps. One other, I definitely want to touch on this. So, we talked about those glue lams. If you work with glue lams a lot, you've got balanced, you've got unbalanced glue lams, right? Your balanced glue lam, is something where you have basically the same tension layers on the top as you do on the bottom, right? An unbalanced glue lam, they're going to put much better tension laminations down there at the bottom. You use that when you have a simple span, right? You just got a glue lam across 2 supports. It's always going to be sagging down, so that bottom's always in tension. So they put tension laminations down there at the bottom, less structural wood at the top, so they can save a little bit of money, and even worse in the middle, basically, because you don't have as much loads going through that. When you have a balanced layout, now you're putting the same, tension layers on the top and tension layers on the bottom. That's when you have a cantilever situation or a multiple span situation, where that beam is sometimes it's curving up, sometimes it's curving down. So sometimes that tension's on the top, sometimes it's on the bottom. And just, obviously I think everybody in here knows, if you have the unbalanced layup on a glue lam, they're going to mark the top with top. If you're ever walking through a building, you look up and you see top written on the bottom of that beam, get that thing out of there. And I actually have seen it, so it does happen up there, but on a balance, they don't mark the top because it doesn't matter which way you put it. So we talked about how they're using a lot of glue lambs in these buildings, right? So when they do this now, again, you have to worry about, the condition when it's going in and the condition after a fire. So they need to protect those tension laminations down there at the bottom. So you can see here on the left, this is just a regular unbalanced layup here with some better tension layers down here at the bottom and not as much up there at the top. If you have a 1 hour rating, now you need, you're going to burn through that 1.8 inches of char right on the bottom in 1 hour. So this bottom tension, that's basically a sacrificial tension layer down here at the bottom. So you need to have a second one. You get to 1.5 hours or 2 hours, you're going to probably get to 3 tension layers down there, tension lambs at the bottom. So again, they have to look at after that fire, after that bottom, 1.5 inches or 3.2 inches or whatever they need for fire resistance rating burns off on the bottom, that beam still has, some good solid tension laminations down there at the bottom. Same thing with balanced, only now you're doing it, from both directions, or if you have a column, again, you're going to need that from both directions. So again, probably not something you're going to catch obviously out in the field, but planner view, somebody said, how much should we be going into this with our structural engineers? I would at least have the conversation with them. If you're reviewing a mass timber building, have that conversation with them. Make sure that they're taking that stuff into account, when they're specifying these glue lambs.
Do these have to be stamped with anything that identifies what type of glue lamp it is?
Yeah, glue lambs are gonna have a stamp on there.
Is it gonna give you enough information to know whether it's got how many layers of tension?
Not necessarily that, they should have some shop drawings with it though, that would get into that a little bit more.
But it's not gonna be stamped. Yeah.
Right.
Okay. All right.
All right, let me see if there's anything. Oh yeah, all right, and then connections. So, we talked about the little clips. We saw some pictures of that stuff, but there's other ways of connecting. Especially walls to the ceilings. A lot of times you're gonna put little angle irons in there, things like that. But however they're connecting these, you need to make sure that connection is not going to fail, right? If you need a 2 hour floor ceiling assembly, whatever's connecting that to the beams or the columns or the walls, you need to make sure that connection gets protected for 2 hours as well, of course. So TR10 actually does go through protection of connections. It gives you a couple different options. One of them is just basically putting a big chunk of wood in there. That's a sacrificial chunk of wood, essentially, to protect that angle iron. Another option here, we'll go to the good one, is putting a couple layers of gypsum in there, right? Again, to make up for whatever time frame you need. So if you need a 1 hour, you might need 2 hours of, or 2 layers of 5/8 type X in there to protect that connection. Here's one, again, putting a chunk of wood in there. So this one, they put 3 2x10s in there, but I do like this because it kind of graphically tells you or shows you a little bit more of what's going to actually happen in that fire. So again, this was the dashed lines here is the 3 layers of the 2x10s. The CLT walls, the CLT ceilings. You can see the brown is what's going to be left after. I think this was a 2 hour fire, and then the grayish stuff there is the char layer. So you can see that angle is still protected by a little bit of wood here after 2 hours or whatever the time frame was on this one. And so that angle is not going to burn out before the drop out, and drop that floor through. All right. Special inspections. I think we might be bringing special inspections in 2021 code.
Yeah.
All right. So special inspections are going to be a thing in Wisconsin now. Yay. So talking to inspectors who have looked at mass timber stuff before, they said it's really no different than steel or concrete buildings for special inspections. It's about the same level of special inspections. you know, a lot of stuff, especially on connectors, that's really where a lot of the, special inspections come in. All right, sealant, I'll jump through some of this stuff just based on time. Again, acoustics, I touched on this a little bit earlier. Well, I'll just take like 5 minutes, run through this last, I'll recap an hour in about 5 minutes for you guys. We'll see how good I am at that. So, you know, airborne sound, STC, you know, that's, you know, you make a lot of noise banging on your drums here and the sound's going out. IIC, your impact, that's, you know, stomping on the ground and bugging people down below you. You typically need a rating of 50. This is what you get with basically just CLT. So the 5-ply CLT for floors here, you're getting an impact rating of, you know, 20s up to about a 30. You need 50. So again, you know, I mentioned that earlier. This is certainly a drawback to it. What they're doing here is, what you'll see a lot of is putting an acoustical map in there above the CLT, between the CLT and the 1-inch non-combustible topping on there. So the 1 inch of gypcrete on there. So, you know, through that, you can usually get your IIC ratings that you need. There's some other stuff now with type 4 HT, because you can have concealed spaces. So you could, you know, drop down like a ceiling a little bit lower and fill in some bad insulation in there. So because you can do those in 4 HTs now, you have a little bit of options there. You can't really do that in, you know, 4A, 4B, 4C, because you need that gypsum to be tight to the CLT itself. Yeah, just some other options here. And yeah, some flanking walls and stuff like that. But and again, that's why, you know, the CLT walls themselves don't really work that well on the interior if you need those sound transmission ratings. You know, that's why a lot of people are just going to do steel studs with some sound bad insulation. Energy, again, yeah, you know, again, all systems on the exterior of the building, so you can get all your insulation in there, just like you normally would. But if you do want to go with the CLT exterior wall, you should qualify that as a mask building, as a mask assembly, and then you get a lot lower R values that you have to meet with that. And again, and that's all based off the 2021 IECC. And then here's that, I mentioned that earlier. They did actually a 7-story CLT building in 2007, shook that all up. There's videos on that stuff on our website if you're interested in some of the seismic stuff. But it was University of California, San Diego. They've got a 10-story CLT building that they just put on a shake table just like 2 weeks ago. So they've been still doing a lot of research on that. I think before that they did a 6-story on the shake table, and I think they did they recreated like the last 5 major earthquakes in California, one right after another. And you know, we'll talk about when we get into the shear wall stuff, but you know, when you do talk about seismic loads, you got mass times acceleration, right? Your acceleration is based on your location, so that's not going to change, but your mass is going to change based on, you know, what you're making your building out of. And wood is a heck of a lot lighter than steel and concrete, so you've got a lot lower of loads, seismic loads, in a wood building than you would in that same building of steel and concrete. That's why these things actually work really well in seismic areas. All right, I think that's kind of where we can wrap this up. A little bit in fire safety. Actually, there's one more thing that I do want to bring up here. A lot of the stuff is not specific to mass timber, just talking about fire safety, so that's in the code norm anyway. But whenever you do have a CLT building that's exceeding 6 stories, you need at least 1 layer of that non-combustible protection on any building elements more than 4 levels below the active construction. So as you start going up, right? So when you have mass timber building that's more than 6 stories here, right? 1, 2, 3, 4, 5, 6, 7 or 8 stories here. As you're actively working on that top level, 1, 2, 3, 4 levels below that, you need to have at least one layer of your non-combustible protection on that layer before you can move on from that layer. So you're protecting that building as you're going up. In the 2021, that also includes putting that 1-inch non-combustible topping on the floors in 4A and 4B. In the 2024, we actually got that taken out to do that 1-inch non-combustible topping during construction. You still have to do it eventually. But they just found that, you know, as they were starting to put that, you know, if they poured out some gypcrete, you'd still have all these people getting in there, buildings still moving around, especially as you're putting on upper layers. It's shifting, so they're getting a lot of cracks in that. So that you still have to do it. You just don't have to do it as you're going up.
Does the IBC have a direct reference to the IFC for this code section?
Oh, yeah, because this is in the FIC. Yes, I believe so. I'll double check on it though.
FYI, John, in order to get to the IFC, even though if the building code, the 2021, identifies the use of the fire code, you have to go to 361.03, parens 1314, to see if there's a directional signal for design and construction for the use of the fire code. So don't forget that mediary step.
Thanks, Rain. So yeah, so here's just a quick example of what that means. You know, you can't go onto the 9th floor until all the, you know, one layer of protection is applied onto the 4th floor. But yes, that is a good point though. This is in the IFC, so I would have to check to make sure that we can jump over to that in Wisconsin. All right, with that, any questions on any of the mass timber stuff? Yeah.
I'm a plan reviewer. You come in my office with a set of plans. How would you handle that? What would you change in your approach to the review of that plan? I mean, my first impression would be, I do a lot of background checking on the engineer who prepared it to make sure they knew what they were doing before I started looking at it.
Yeah, and I think what, you know, what we've been encouraging, what Woodworks is encouraging is go in and have those conversations as early as you can with the plan reviewers and especially in the fire department as well. You know, just even as it's an idea in the back of your head, go in there, start to have those conversations with them and say, you know, here's what we're thinking of designing. You know, we've got, you know, this is our structural engineer team, this is our fire protection team. And just start to make sure everybody's comfortable with it yeah, but otherwise it's really, you know, as a plan reviewer, I just start with the code and go through it, you know. Yeah.
As you start getting into some of the higher rise buildings, you know, specifically, you know, every like 20 floors or so, they might put in like an electrical substation. Some places want to have UPS systems. You're storing hazardous materials that are flammable, and with electricity, obviously, if that shorts out, you could. Do those floors need to have any special treatment?
I haven't heard that they do yet. So I'm not saying no, they don't, but at least I haven't heard of that yet. Right, just
One other item for everybody listening. The department has, in the process of creating kind of a summary, similar to the guide that you just passed around, but specific for Wisconsin for heavy timber, mass timber construction. I don't know the timetable on that. I know it's being worked on and as I speak. We're hoping that it'll be available for the public to review and obtain either the website or other means at the time when this code goes into place, which will be hopefully preferably later this year. I'll leave it at that.
it's a good way to put it. Yep.
Yeah, I know the Forest Products Laboratory has done some testing on this, but I'm curious, looking forward to twenty twenty-four and beyond. Where we're at with the code recognizing chemical treatment for fire protection for mass timber and other composite lumbers.
Yeah, you know, a lot of it's gonna come just from what testing's available when they put the stuff into the code. You know, people ask all the time about, you know, putting incandescent paint on here and, you know, is that gonna work? And what I'll typically tell them is that I think if they had the tests that prove that it worked, I think it would be in the code already. So, but there's always, you know, improvements in it. There's always changes. There's always more testing getting done. So, yeah, you know, I'm sure some of that stuff's going to at least try to get into the code at some point. Whether or not it does, it's gonna depend on what they can and can't prove. But yeah, you know, you brought up Forest Products Lab. You know, they're doing a lot of testing. You know, I just watched some tests from them a month or two ago. You know, so they're still doing a lot of testing. The Rise up in Sweden's doing a lot of testing. So yeah, especially now with the improved adhesives and everything, I think that, you know, 2027, 2030 code, you're gonna see a lot more bigger, taller, maybe even less non-combustible protection as people start getting, you know, used to these buildings and they start to see what the problems are with them. So yeah, I've already talked to a few people who are trying to come up with a few code changes for this stuff. At the Wood Council, we had a bunch of people that were on that ad hoc committee and they kind of say, let's just leave it alone for 2-3 cycles. Let people use it, let people get used to it, and then let's look at making some improvements and changes. But yeah, there's a lot of people, because there are so much testing that's going on with this stuff, that they know that it's going to, you know, work a lot better than what's in the code. So they kind of want to push this stuff a little bit faster, but yeah, it's getting everybody on a comfort level with it, I think. You have something?
Yeah, you mentioned that getting it into the code would take more testing, just in general, so people are comfortable with the method used protected. But in the interim, say someone who does want to use incandescent paint as a sacrificial layer, couldn't they just send an ESR report with the product they want to use?
Yep.
And, you know, I want to use this incandescent paint with this company's CLT.
Yeah.
That would be a really easy way for someone to submit a design that's not, you know, written in the code and say, yeah, it's tested and proven. Because if someone has to go pay for the ESR testing at that point.
Yeah, and that's where, you know, and they do have that option in there for the non-combustible protection. You know, you have a performance option, you know, go test it and see what you come up with. Again, it's very expensive. I don't see a lot of people doing that stuff, but yeah, we're so lucky having Forest Products Labs here in the state. So we can all kind of watch what they're doing and talk to people and hear what they're doing a little bit sooner than throughout the rest of the country. And that's where, you know, I know the mass product or the mass timber task force committee, you know, they're coming up with a kind of a guideline on how to approve a variance to go above and beyond the code. We're actually working on one, AWC, we're doing one for Florida, the state of Florida right now as well, because they didn't adopt the mass timber stuff in 2021 yet. But we wanted to come up with a guide for them of, you know, here's how you can approve, you know, a variance or an improvement method materials approval for a mass timber building, not just with what's in the code, but if you want to go above and beyond, you know, here's some of the things that you would want to look at and take into account. So, yeah, you know, codes are always so slow to keep up with the latest testing and the latest, you know, ways of doing things. And that's why we have alternative means materials, and that's why we have variance procedures to, you know, allow us to, you know, take a look at that and make a sound, rational decision that, yes, I'm comfortable that this is going to work and we can build a building to using this test data. Okay.
For penetrations, you had mentioned earlier, it's basically the same as going through like a PT deck, but are there a whole array of tested products already, or are we gonna be looking at engineering judgments?
No, yeah, they're out there. I don't know if everything's been tested to it yet, but I know that there's definitely a lot of very common ones out there that have been tested for this and that they're out there using right now.
All right. Let's jump over to the other program then. And actually, while I'm calling this up, so you guys don't have to sit here and watch this, why don't we take a 10-minute break? We'll do this now instead of at 2 o'clock, and we'll come back at 1:45, and then from there we can run through this whole program without taking another break then. So we'll do a quick 10 minutes here.
Virtual group will be back at 1:45. Thank you.
Just wait. Oh, if you haven't also, please sign the sign-in sheet if anybody hasn't done that. Question for you. Is it related?
It's based on course. It's gonna be about 10 by 10. So if you've got a 40-foot high ceiling in there, you got all. Okay, good. I just wanted to clarify that.
Everything, yeah.
Yeah, I think there's champ, I think there is champ. I think it was. Yeah, I agree. Because there was. There's times where I wish I could kind of grab a couple. Portion of the things. So there's. Previous one. Yeah. I was doing this about, but you. All I know is. I know it's not today, you can see the links. You won't really look at it. But I don't see you clarify that the buildings. It was way up to me, way from there. It was giving me the Easter eggs, and I was there. Yeah. It was giving me the PBGs, and I was standing. Trying to do it the best I can. Yeah, when they say, oh, it's like, it's very low. Like, it's so late. And we have to go out there. Yeah, there are times I wish I could be there. Yeah, I mean, this is not, maybe a year or two. Yeah, it's when I work with some wood ones, I just don't. You could get me. Yeah, it's not. We're getting. Yeah. Usually, a builder export everything. Well, that's why I went to this because I usually one time. Yeah. And and I like yes, it's fine. Yeah, I got to look up for it. They would like to go to Wisconsin. I didn't even look at it. They expect to look at it, so it goes, and said, yep. So, yeah, I'm not much of a, I'm using that. Not a great guy. Yeah, so like chemistry building. So they had, so we will say, yeah, so the board. And by the way, I had about 12. Went to
Is there Wi-Fi? Yeah, I use the guest. Don't forget.
I'm a person, but I was. I can say. Hey, listen, oh, I see what you're saying, yeah, right. We're not costing you a thing. No, that's just, no, here's the next one. I think the big thing is what, okay, we have. That's the. I signed that code with some of these schools. I would love to have. I was about Southwest. That's me. Please. Why are? This is pretty positive. I'm hoping for us tonight. I think that hospital. That's a bumper. Oh, water versus kick. Out of this. If you're afraid to work. So yeah, unless you get. Yeah, I mean, where's the president's income coming from? That's why it's. Whoever did whoever got any session with you with that scar. We are, but yeah, need to say what is always.
This one I never got. Never wrote business agreements, but with the mass timber one, I've done that. It doesn't.
Thanks, Mike. I'm just.
The first few, I pretty much had the city screen, just kind of weird. Now I don't do read through it, but every now and then I go back through the notes. I've been forgetting the stuff.
Yeah, that's what it was. And there's 4 stacks. Things that, you know, they real close. And
There's 30 beers, and that's for, yeah, so the SunPower, they had to send them back to Austria to have them re-engineered. Yep. But they only had like 3 games. They can't do it on the story building. Yeah. Like I said, that's why the design side is not longer.
They don't want to do that.
Send it to get on me and me. All right, we get started about a minute here.
Nobody can go through the election and say, well, yeah, that from the state statute, they need a pretty more training better. We include this new money for this. This move. We need this. That's the film. And you gotta continue to. Are you ready to roll?
Yeah, in No, I was just giving about another 30 seconds, but I can get started now if you want. Get you guys out of here 30 seconds earlier there. All right. So the next little bit here, we're gonna talk about some shear walls. Actually, when Lucas came out, he asked me to come out here, start doing some of this stuff. This is kind of how it started was, you know, can you come out and do a full day on shear walls? And I said, well, no, because I would put myself to sleep doing that, but, you know, so I said, yeah, I'll do some mass timber stuff. 'Cause that's cool and interesting and everybody needs to know that stuff as well. So, but we do want to get into shear walls a little bit. You know, I think one of the things that you guys are starting to see is it's a lot of different structures now that aren't using the traditional shear prevention method or lateral prevention methods. So, you know, the AWC does walk you through prescriptive design of shear walls, you know, brace wall lines, brace wall panels, real similar to what the IRC or the UDC has. So I'm not really going to get into that stuff at all because that's all pretty straightforward in the code. You know, you can look at that and, you know, it walks you through, you know, put brace wall lines here. Here's how you make your brace, your panels or your lateral resistance and, you know, follow this recipe and you've got yourself, you know, a shear wall. But, you know, we're starting to get into a lot more bigger buildings, stranger buildings, oddly shaped buildings, things like that are, you know, can't conform to the prescriptive requirements in the code. So this is sort of a high level view because, you know, each project's going to be very specific on, you know, what it is, where it is, all that type of stuff. But I wanted to go through a kind of a high level overview of here's how, you know, shear walls get designed without using the prescriptive methods. You know, here's kind of the steps that you have to go through. Here's the tables. Most of it all comes out of AWC documents again. And so, yeah, so this is kind of the engineering approach to designing shear walls. You know, and that's, I usually bring this up at some point whenever I'm teaching, but you know, you got your prescriptive method that's in the code, you've got your engineering analysis. That's pretty much your two ways of designing just about anything. You know, I liken that to eating you know, you want to eat some mac and cheese, right? You can go to the store, you can buy a thing of Kraft mac and cheese off the shelf. Go home, it gives you the cheese, it gives you the noodles, it gives you the, you know, instructions. You make yourself a bowl of mac and cheese and that's your prescriptive method of eating mac and cheese. You don't get any variation in that. It's very much, you know, you want mac and cheese, here's your bowl of mac and cheese. We'll give you everything that you need to do that. But now if you want different noodles, if you want different cheese, if you want, you know, a different sauce to it, if you want more than what they give you in a box or less than what they give you in a box, now you're getting into engineering analysis, right? Now you're going out, you're buying your own noodles, you're buying your own cheese, you're buying your own sauce, whatever you want to put in there, breadcrumbs, you know, bacon, whatever other toppings you want in there. Now you're getting into engineering analysis, right? So, you know, if you just have a very basic building, you know, nice and square, you can follow the guidance in the code, the prescriptive requirements. You can have all your shear resistance in there. If you have a building that doesn't conform to that, now you got to go through engineering analysis, and that's again what we'll kind of cover here. Again, wood council stuff, disclaimer, and skip through all those before. Course description, you know, again, we'll go through shear walls. I'm mostly just doing wind with you guys and not getting into seismic because hey, we're in Wisconsin and all my engineer buddies across the country are jealous of, you know, we rarely have to touch seismic down here other than, you know, a little bit in the south, but the objectives again, you know, going through the engineering practices. We kind of saw a slide of this earlier under the other presentation, but again, you know, based off of whatever code you're using, make sure that you're using the correct reference standards. You know, go back to chapter 35. You know, you can't use, you know, we're going to be coming out with a 2024 NDS pretty soon at the Wood Council. If you're on the 2021 IBC though, you can't use the 2024 NDS unless you're going through a variance process or something like that. But you know, the code references the 2018 NDS, so make sure that you're using the proper code for that.
Similarly, AWC, we have our SPID, what we call the SPID whiz guide. And I realize it's SDP, but we pronounce it SPD. I don't know why it was, they pronounced it that way since long before I got there, and they all agree that it's not, they don't pronounce it correctly, but we call it the SPID whiz guide. And that's the special design provisions for wind and seismic. All right, and that's gonna walk you through, again, wind and seismic. How are you designing diaphragms, shear walls, all that stuff based off of the building that you have. Right now, you know, Wisconsin's on the 2015 IBC. We're using an older version of the SPIDWIZ. We're using the 2018 SPIDWIZ, or the 2015 SPIDWIZ. With the 2021 IBC, though, we're jumping up to the 2021 SPIDWIZ. If you've used the old guide before, the new one's definitely got a few different things to it. The tables are a little bit more condensed, and I'll point that out whenever we get to that. Yeah, there's definitely a few different things to it now. So in the IBC 2021, general design requirements for lateral force resisting systems, that's where we're in, right? So structures using wood frame shear walls to resist wind, seismic, or other lateral loads shall be designed in accordance with the SPIDWIZ guide. Alternative prescriptive options can also be found in section 2308. So again, you know, the IBC itself basically tells you, go use the SPIDWIZ, the guide that we have. And actually, I'll start this one earlier this time. I'll send this around. This one you can download for free on our website, though. So if anybody wants to look through this, it starts off with connections and then lateral force resistance systems, and then a few comment or appendices in the back. You guys can kind of see what that's in there, but again, free on the website. But basically, the IBC tells you, hey, go to that book, design wood frame shear walls that way. Alternatively, though, we've got some prescriptive requirements, real similar to what we have in the UDC, just on a bigger scale, essentially. All right, the 2021 SPIDWIZ is the current edition. So we're actually going to skip the 24. We'll have a 27 version out at some point, but sheathed wood frame shear walls are in sections 4.1 and section 4.3. It's referenced in the 2021 IBC. There's different adjustment factors now for wind and seismic, and then there's also if you're designing for ASD or LRFD, both of those are in there. In older versions of the SPIDWIZ, there actually used to be different tables for wind and seismic, or there was one big table, but half of it was for wind, half of it was for seismic. What we've done in the 2021 now is gotten rid of that. We just have one table, and then there's an adjustment factor if you're doing wind or if you're doing seismic. And then there's also an adjustment factor if you're using ASD design or LRFD design. So when we're talking about lateral loads and shear walls, when do we need them? Well, everybody knows gravity loads, your dead loads, your live loads coming down on the building. Lateral loads are more those sideways loads, of course, right? So wind and seismic. And then force is equal to, your pressure times your area, right? So you've got whatever your surface area is, you've got some pressure blowing up against there. You've got, wind blowing this way into that building, which is going to push your end walls are going to push your roof back that way. Your wind is going to actually suction and pull it back that way. And then your shear walls are actually going to be pushing back against that, trying to resist that load, right? Every load needs an equal and opposite direction load, right? So you've got the wind blowing this way. So your shear walls down below have to push back against it that way. And here's your general modes of failure. So you've got uplift, you got base shear, you've got racking. I don't like the animations there. And then you got overturning. There you go. But each of those are a different mode of failure for shear walls, right? Your uplift, obviously your building just pulling right off, your base shear sliding right off. Racking, it's kicking off the side, your foundation is set. Racking is the one where, you've got this thing anchored down pretty well, but nothing's keeping it from racking over. And then overturning, maybe some of it's down right, and you're kind of a combination of uplift and base shear then. All right, so your elements of a shear wall. You got wood studs, 12, 16, 24-inch stud center. You can use any of those. Wood structural panel sheathing, OSB or plywood, which is gonna be nailed in. You can't use screws in shear walls. You got your top plate, your bottom plate, your elements at the wall ends that are designed for the overturning, and then your connections to the top and bottom for that shear transfer. That's the basics of what you have in a shear wall, right? So again, here's a little bit more, you've got, my pointer doesn't work on the screen, but, so you've got, again, that wind is blowing over here, it's blowing that roof, trying to shift that over, so you've got all this shear load pushing up at the top of that wall. And so now all your anchor bolts and your hold downs down here at the bottom are going to be resisting back against it, right? And eventually all those loads have to get transferred down into the footings or foundations. Why do we use nails? Well, nails have really good strength and good ductility. If you look high strength, poor ductility, that's more like bolts, right? Anchor bolts. They're going to have really high strength, but once they go, they're just going to snap, right? Down there at the bottom, you've got screws with low strength but good ductility, or screws and some other fasteners like staples and things, where you have low strength, but they're very flexible. And then nails are right there in the middle. That black one, they've got high strength and they have good ductility, right? So they're going to move and be able to shift a little bit without snapping. So you've got 3 different types of shear walls in the SpidWiz guide, right? So you have individual full height wall segments. Let me just All right, so you got your individual full height wall segments. That's your traditional method. That's your current code. It goes back into the 1950s, but you have a hold down at each end of the full height segments. And then openings are only permitted beyond the shear wall itself. So when you have windows, when you have doors, you've got a shear wall panel and you hit a window or a door and that stops. You need a hold down at both sides of that, right? Some way to hold that down. We'll get into these a little bit more. The next one is force transfer around openings. This is similar, but now when you hit openings, you're actually going to transfer those loads over, right? You've got framing members are designed for force transfer around the openings. The length of each pier shall not be less than 2 feet in between there. And then you have a full height wall segment on each end, and that's where your hold downs are. So you can see these straps that are above the window there. That's actually what's going to transfer that load from one side to the other. So you've kind of almost got, you almost have like individual full height wall segments here, 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 here. And then these straps are going to transfer your load from one to the next. So you keep going through. The strap length. Again, we got those straps going up above the window. You also need a strap up at the top that's going to transfer your shear loads from your diaphragm down into your wall. Okay. But above the openings themselves, there was a code section in there that used to say your straps have to be continuous throughout the entire length of the wall. People are getting the straps above openings confused with the straps from the diaphragm. So now in the 2021 SpidWiz, we revised that section to say collectors for transfer of shear forces between the diaphragms and the shear wall shall not be less than the full length of the force transfer around opening shear wall. So those collectors between your diaphragm and your wall, you need a full collector along that, a full strap, right? That's going to transfer those loads from your diaphragm to your walls. But right, and so that's that dash line up across the top there. But your ones around the openings themselves just need to be long enough to transfer the loads from one side to the other around that opening. And then again, here's where you have your hold down devices. So you've got one on this side, one on that side. Like I said, this was a full height transfer or a full height shear wall. This piece would need hold downs on both sides.
If you've got one here, you would need to hold down on both sides. So this way you can reduce the number of hold downs that you have, but now you need to transfer those loads throughout. Then the other one's perforated shear walls. That's the third option that you have. So framing members are not designed for force transfer around openings. Perforated shear wall, or a perforated shear wall segment is required at each end. They should have uniform top and wall and bottom wall elevations. And then your height shall not exceed 20 feet. We'll get into what each of those are a little bit more, I think, as we go. The maximum shear wall aspect ratios. So you have a height to width ratio that you have to at least meet with each of those different options. So if you have an unblocked wood structural panel, you've got a 2-to-1 ratio that you have to. That's your maximum height to width ratio. You don't want these, you know. Well, we'll get into that in just a second here. I thought there was a graphic next, but so for your full height wall segment shear walls, your height to width must not exceed 2-to-1 or 3.5-to-1, depending on the method used. So we'll go back here. You know, if you have blocked, you're at 3.5-to-1, or structural fiber board down there, you've got 3.5-to-1. So that's where your aspect ratio comes in. So those wood structural panel shear walls with an aspect ratio greater than 2-to-1 shall have an adjustment factor, so you can get into some thinner walls if you need to. There's an adjustment factor in the code then. And then structural fiber shear walls with an aspect ratio greater than 1-to-1 shall have an adjustment factor as well. Force transfer around opening shear walls. And again, a lot of this introductory info we'll get to now, and then we'll get into some examples. So I think some of this stuff will be a little bit clearer of how we use this stuff in a little bit. But force transfer around openings, height to weight, or the height to width must not exceed 2-to-1 or 3.5-to-1 again. The height of a wall pier with an opening on one side shall be the clear height width of the pier on the side of the opening. So the height of a wall pier with an opening on one side shall be the clear height. So again, that's your size of your wall pier. If you've got a window, if you've got a door, now you can come all the way down here to the bottom for your wall pier. It's whatever that opening is next to it. That's what your height and width for your wall pier is going to be. The height of a wall pier with openings on both sides shall be the larger clear height on either side. That would be, you know, if you had something on between that door and the window, it would be whichever's smaller than. Perforated shear walls, again, 2-to-1 or 3.5-to-1, depending on the method used. Aspect ratio is greater than 2-to-1, have an adjustment factor. And then portions with an aspect ratio greater than 3.5-to-1 shall not include the sum of the overall shear wall length. So again, now you've got those openings, but again, now you're full height on there. All right, so that's kind of what each of those methods are. And again, we'll pick those out as we go, but so your base shear capacity, that's found in tables 4.3A, 4.3B, 4.3C, and 4.3D. And that's based off of which method you're going to use and the materials used. Your base shear capacity is then multiplied by a factor found in 414. And that's where you get into either ASD or LRFD, whichever design that they're factoring or the engineer's using, and then whether you're using seismic or wind. And then if you're unblocked wood structural panel shear walls, there's an additional adjustment factor that's used. So we talked about the base shear capacities in 4.3A, 4.3B, 4.3C, 4.3D. So this is what those kind of look like. So 4.3A is your shear capacity of sheathed wood frame shear walls. I know this might be hard to read back there, but you've got wood structural panels with structural 1, wood structural panels with sheathing. You have your thicknesses on here. You've got your nail bearing length, your types of nails, your panel edge spacing, and then the values that you can use for your shear capacity then. And then that's broken down by OSB or plywood, whichever materials you're using in there as well. Footnotes are always pretty important. Oop. The footnote number 2 in there, nominal unit shear capacities are permitted to be increased for values of 5/32 nail sheathing with the same nail patterns provided with nailing provided. A, studs are spaced a minimum 16 inches on center, or B, panels are applied with long dimension across the studs. So yeah, so if you're using 15/32 sheathing, you are allowed some different adjustment factors in there. For species and grades of framing other than Doug fir larch or southern pine, reduced nominal shear capacities are determined with based off the specific gravity of the wood. So, you know, somebody can come in with, you know, any type of wood for a shear wall. You know, these values are all based using Doug fir larch or southern pine. But if somebody wanted to come in with different wood and use that, you would use a ratio then of their specific gravity to come up with those shear values. The other one I wanted to mention down there, galvanized nails should be hot dipped or mechanically deposited. And galvanized box nails shall be permitted to be substituted for the common nails in the table below. So what you'll notice as I jump back here to 4.3A, all your nailing options in here are all common nails, right? So that's all that they give you for that, but you can use galvanized box nails based off of this adjustment factor down here. Actually, it's not even an adjustment factor, that's just the equivalence factors down there. And then where tension force induced by shear wall overturning is resisted by a hold down attached to the inside face of the end post. Nominal unit shear capacity for shear walls using 10D common nails shall be multiplied by 9.92. So again, if you have your hold down factor and you're actually putting it on the inside face of the end post, you're going to have to reduce your capacity by about 8% there. We'll see some pictures of that, I think, later on. All right, so 4.3B, that also gets into kind of that same sheathing material, but this is wood structural panels installed over 1/2 inch or 5/8 gypsum or gypsum board sheathing. So this is where some gypsum wallboard on there, and now you're also applying the wood structural panels over that. And so you get different values for that. You can get a little bit increased shear capacity. Very similar footnotes in there. So again, you know, if you're using something other than Doug fir larch or southern pine, you've got the adjustment factor for the specific gravity. And then you've got the galvanized box nails equivalency to the common nails in there. 4.3 is let's see, gypsum board, gypsum lath and plaster, or Portland cement plaster shear walls. So if you do want to do a shear wall based off of just gypsum wallboard or water resistant gypsum backing board, Portland cement plaster, anything like that, you can. There are design shear values in there for designing it for those types of shear walls as well. And then 4.3D, that's lumber shear walls. So single layer horizontally sheathed lumber, double layer diagonally sheathed lumber. So if you're going to put you know, some sheathed lumber on there in a diagonal fashion on one side or on both sides, there's your shear values for that as well. These are those adjustment factors I brought up earlier. So again, if you're using this for seismic design, that's 4.1.4.1, which you don't really have to worry about that too much, but 4.1.4.2 is for wood design of diaphragms and shear walls. The ASD allowable factors shall be determined by dividing the nominal shear capacity in 4.1.2 by the ASD reduction factor of 2. And if you're using LRFD, then multiply it by the nominal shear capacity by a resistance factor of 0.08 or 0.80. Like I said, in the earlier versions of the SpidWiz, there would actually be those tables that we were just looking at here. these ones, you would have where it talks about the panel edge nail spacing here. You would have one of those for seismic, and then right next to it, you would have one for wind as well. And you would have to pick one or the other. What we did now is just came up with one table, so it's a little bit easier. And then applying that adjustment factor, either reducing it by half, basically, if you're using ASD, or multiplying it by 0.8 if you're using LRFD. All right, so unblocked wood structural panel shear walls. Based off your stud spacing, there's your nailing. The unblocked shear wall height is limited to 16 feet. I know that there was a project out there with 20 feet that they were trying to use here in Wisconsin, so.
Have you ever seen that done?
I haven't, no. And neither had anybody else in my office, so I sent that around to everybody there, and they had not run into that before. They did actually go back though and look at all the testing that was done on these unblocked shear walls. And they determined that they think, the engineers that I was talking to, I don't think they were around when this section got written into the SPIDWIZ, but they think that the only thing that they could figure out for why that's that limited to 16 feet was that's what was tested at the time. That was their test capacity. The room that they put it in had a limitation of a 16-foot high wall. And so that's what was tested. So going above and beyond that, nobody really knows what's going to happen. They, at least we haven't tested it. They talked to a few structural engineers up in Canada who did a lot of shear wall testing, unblocked shear wall testing. They hadn't heard of anybody go over 16 feet yet. So that's sort of why that limitation's in there, as far as we could tell. So if they want to go to 20 feet and they want to use engineering analysis, I don't know what engineering they're going to use, how they're going to, analyze it. But again, it's you just got to kind of see what they come up with and see if it makes sense or not, or tell them throw in some blocking into it. All right, so let's see if we can kind of bring all this together and start to see how this all plays together. All right. So design example number 1. So we've got a 8-foot high by 4-foot wide wood structural panel shear wall with 7/16 structural 1 OSB installed vertically with 8 penny common nails, 6-inch panel edge spacing, 2 by 6, 24 inches on center. We'll find the shear capacity. So again, so these wood structural panels, right? You basically pop these things in anywhere in your building then, right? So if you have an odd structure, if you have a larger building, you can take this 8-foot by 4-foot panel, plop it in anywhere, and that's going to give you a certain amount of shear resistance, right? So then you're going to plop in a bunch of those basically to resist whatever wind load you have coming up against there, or whatever lateral loads you have coming up against it. So first off, we want to check the aspect ratio. So height to width. So 8-foot to 4-foot is a 2-to-1 aspect ratio. So we're okay there. And then we would check the table value. So design example 1's pretty simple here. So we're going to go to 4.3A, which you looked at earlier. And we've got wood structural panel structural 1 was the sheathing material that we talked about using. We said 7/16 for thickness. We had 8 penny common nails. We had a 6-inch panel edge spacing. And so we have a 715 pounds per lineal foot of shear capacity. We checked through the footnotes, and none of those applied to the one that we're working on here. So that's good. On the shear capacities, I'm going to say if they're designing this with using ASD, so they're going to divide that by the ASD reduction factor of 2.0. So we had 715 out of that table. We're going to divide it by 2. And if they're using ASD to design that building, that they're gonna have 357.5 pounds per lineal foot of shear resistance on that, okay? So because we have a 4-foot panel, that 4-foot section of wall can resist 1,430 pounds of lateral force pushing up against it, all right? Simple design example. But any questions on that?
Is the field spacing unimportant for the fasteners? I didn't notice it's not on there. So
On the hold downs or the,
just what you're nailing the sheathing with, it said 6-inch edge, I think, and didn't it?
yeah, the field spacing is going to be 6 inches no matter what. That's always. Yeah, that's in the code, there's in the SPID with design as well, so it's always gonna be 6 inches.
Okay.
Throughout that, so, yeah, and that's whether you have 4-inch edge spacing or 6-inch edge spacing, no matter what, you're always 6 inches in the field. All right, design example number 2, so we'll, this one will have a little bit more adjustment factors and things with it, so. Given a 8-foot high by 2-foot 4-inch wide unblocked wood structural panel shear wall here. 7/16 OSB sheathing installed vertically, 8-penny galvanized box nails this time, not common nails. 4-inch panel spacing, 2x6 spruce pine fir studs at 16 inches on center, and we'll design this one with LRFD. All right, so this time we've got 8-foot to a 2-foot 4 aspect ratio, which is 3.4 to 1, which is greater than the 2.1 that we would have for that type of materials. For 4.3.3.3, an adjustment factor of 1.25 minus, that equation is required if an aspect ratio is greater than 2.1. So for that, we've got 1.25 minus an eighth of 8 divided by 2.33. And so we have an adjustment factor of 0.82 that we're going to have to apply to that. All right, so come through here again, now we have wood structural panels with sheathing, not with structural 1 on there. We still have 7/16. We still have the 8-penny common, or actually we had box nails this time, but we're going to go into the factor with the common nails because that's all that's in the table here. 4-inch panel spacing, so we've got 980 pounds per lineal foot. But let's check through the footnotes on this one. So that first one, nominal unit shear capacities are permitted to be increased to values shown for 15-30 seconds with the same nailing pattern, provided that A, the studs are spaced a maximum of 16 inches on center, or B, the panels are applied with the long dimension across the studs. So before we were at 980 because we were using that 7/16. What this is saying is as long as the studs are spaced a maximum of 16 inches on center, which is what we had for this example, we can actually use the 15-30 second numbers on there. So if we go back into the table there, we go down to 15-30 seconds, we can actually use 1,065 pounds per lineal foot. Keep checking the footnotes, right? Now we've got a species other than Doug fir larch or southern pine. And so we have to look at the specific gravity adjustment factor on this one. So spruce pine fir specific gravity of 0.42. So you put that into the equation in footnote 3 there, and we come up with a 0.92 adjustment factor for that one. And then let's keep checking because we did also have galvanized box nails. And so we did have basically making sure then that our 8-penny galvanized box nails meet the same equivalency as the 8-penny common nails. So we're actually okay there with using the galvanized box nails. All right, so going into LRFD design, we're going to multiply that out by 0.8. So now we put everything together. So we had that 1,065 pounds per lineal foot. By the way, I'll share this presentation with you guys so you guys don't have to
take too many notes on this stuff, I'll send this out to Lucas, so you guys get all these, you guys kind of follow through all this stuff and get all these code sections and equations and all that stuff together too. So 1065 was the base value, because again, we can use that at 15/32 sheathing size. We have the LRFD adjustment factor of 0.8. We have the aspect ratio adjustment factor of 0.82. We have the specific gravity adjustment factor of 0.92. So that ends up with 642.75 pounds per lineal foot. And so with a 2 foot 4 inch section of wall, we can resist about 1,500 pounds of lateral force that way.
Is there any table or adjustment factor that would allow for clip head nails like you see at a gun nail typically?
Not here, no. So yeah, if you're gonna use, clipped head nails, anything like that, you would have to go in. I shouldn't say you can't do an adjustment factor. What you would have to do is you would have to find the equivalent structural capacity from that to the nails that are in the table there. So iSanta has a really good ES report on all those different types of nails and stuff. I don't know if you've seen that one. They're ESR 1539, I think it is.
And that's allowable to use.
Yep. So that's how you would get that adjustment over. So yeah, you'd have to look at what kind of shear capacity those nails are coming in with, look at the shear capacity of what these nails are. And I think you just take a straight ratio. I'd have to look. I think that is called out in the SPIDWIZ of using other nails, using the yield capacity of, if it's not in the SPIDWIZ, it's in the NDS for sure. On how you can compare those different nails together.
Something that's that, because I've seen on some of the plans that I've looked at that had that correlation, and it actually had the clipped head nails, but then what else was some around, some should around it.
Yeah.
And they had that, but the nail diameters are different than 8 pennies or whatever, 10 pennies. So there was a different one in the spacing changed.
Yeah, so yeah, I know the NDS one, so you can coordinate through the NDS back into the SPIDWIZ for using different nails that way. So yeah, that's how you would have to approach that then.
It's pretty common to run across the building where they aren't even thinking about shear walls, and they've already used all the clip head nails. Now you have to figure out how to fix it.
The worst thing is oversinking.
Yeah, very.
Yeah,
They're,
Yep.
you know, especially in OSB.
yep,
You know,
and actual,
CDX isn't gonna be so bad, but you go into OSB, and depending where the compressor's at.
Yeah.
You know, if you go
You're
and push
going
one
right
right
in.
inside, you can probably push the shoe.
right, yep. Well, and yeah, and to your point of, they're just gonna run out there, do whatever. I grew up, my dad had a drywall and steel stud company growing up, so that's why I went into the wood industry, but everything in my house was put together with drywall screws. He built a whole garage using drywall screws. We had chair rail in our basement that was put to the wall with drywall screws. So that's like a rustic, big fastener look to it. So yeah, exactly. Contractors, no offense to the contractors, but you get some of the contractors, I'll put it that way, who are going to use whatever they have on the truck from the last job and just run with it. So yeah, that's definitely something though, to keep an eye on out in the field. If structural engineer went through and just said, you've got full round head nails on here and they're using a nail gun, yeah, you're probably gonna have some adjustment factors. They're gonna have to add in a few extras or do something a little bit different with that.
Does it address about the depth of the nail installed?
Yep. So that was the LRFD, about 1,500 pounds. We'll get to some of that stuff in a second here. Just for comparison, if the structural engineer was actually using ASD design, I don't know, I should have explained it too. So, ASD allowable strength design, you're just basically taking your loads and your resistance and comparing the two, right? When you get into load factor resistance design, now you're putting factors onto everything. So your loads, you're putting a safety factor onto it, and then your materials, you're putting an adjustment factor onto that to kind of compensate for variations in the materials, basically. So that's how the two different design
options, I guess, kind of work, but if they're using ASD, again, then they're taking that 1,065, dividing it by 2 for that ASD adjustment factor. So if they're using ASD design, now you're at 936 pounds of lateral force, is what they can resist. Again, on LRFD, they were at 1,500 almost pounds. But again, LRFD, they can resist more lateral force that way, but the loads that are getting applied to it have an adjustment, a safety factor adjustment added to it, so the loads are going to be higher. So that's why you need that's why it ends up working that way. Let's see, deflection. When you do have, usually you're going to have a lot more than just one little shear wall panel in a building. You're going to have multiple out there. You do have to watch for the deflection on those, because if one panel deflects, a half an inch, and I don't think we get into it in here, but if one panel deflects, a half an inch, and the next panel down deflects an inch, you're going to have some issues there, right? So you have to make sure then that if this one's going to deflect an inch or a half an inch, that this one can only deflect a half an inch. And so you have to, there's some adjustment factors in there to make sure that you're only allowing that other panel to deflect a half an inch. Why would one deflect differently than the other? It could be a thinner panel or a narrower panel. They could use different materials on it. I doubt that, but so if you have a smaller panel on one side, a bigger panel on the other side, that smaller one's going to have a lot more deflection to it than that other one will. So I didn't really put that into here because it is a very time consuming calculation and everything to go through. But if you notice back, let's jump back a little bit here. There is also this G factor that's in here, and that's based off of your OSB or your plywood. And that's going to be what you're taking into account with your deflection. That's a kind of a deflection factor. And so when you get into that deflection, you need to find the deflection for each segment using equation 4.31, which is down there. Use the smallest deflection as the deflection limit for all your segments. So you almost have to work backwards then. So you find your deflection for your segments, figure out which one has the smallest deflection, and then work back through each of those equations using that smaller deflection as your limit for those other ones, and that's going to come up with some of your shear resistance. So there's some info in the commentary. There's again, that whole section in there on that. So if you do get into that, where again, if they're using pretty much the same, 8x4 panels all the way down, the same materials, you're not going to run into any issues with it. But if they have an 8x4 and then like an 8 by 18 inches or something, yeah, that's definitely something then that you're going to need to take a look at. All right, details of the shear wall construction. So minimum 2x framing and blocking members. When design is blocked, all panel edges are required to be over and be fastened to a framing member or blocking. Framing members are permitted to be doubled, provided they're fastened together per the NDS with staggered fasteners. And we'll talk about staggered fasteners in a little bit. Fasteners shall be nails or other approved fasteners. Nails shall be driven flush with the surface of the sheathing. So we'll see that in a second, but that is a requirement. It's supposed to be flush. Nails on intermediate members are either 6 inches or 12 inches, depending on stud spacing and panel thickness. So that's down those center. Yeah, so there are some instances where you can use 12 inches on center. And then adhesives shall only be permitted to be used alone in wood and low seismic locations. So you could use an adhesive to help out on your shear capacities here in Wisconsin. So the shear wall systems, these are what those tables kind of gave you your values on, right? So these are the different options that are put in there for, if you're now we have that, that panel size and everything, but how can we actually put that together? So we have wood structural panels, particle board, structural fiber board, gypsum board, plaster, a single layer of diagonally sheathed lumber, a double layer of diagonally sheathed lumber, horizontally sheathed lumber, and vertical board siding. You know, the diagonal boards, they don't get used all that much anymore, I don't think. At least I haven't seen those in I don't know how long. But really, that's probably your best way of designing a shear wall. You know, you making a triangle out of your building is going to be very strong. So anytime you can kind of have those diagonals and that's going to help you. That's where you're going to get your higher values. But again, it's a lot of construction, so a lot of labor on that. So you don't see that too often anymore. All right, staggering fasteners. I mentioned that a little bit earlier in here that fasteners shall be staggered. So, you know, splitting occurs when you have two nails that are really close to each other in a straight line from each other, right? So you can see right there in the middle picture, we've got two nails pretty much right in a straight line with each other, and you can see that split that's happening in there. You need to avoid that split in there because now you're starting to lose, you know, all the capacity of that nail. Keep in mind, you know, splitting never happens across grains, right? So here, you know, you can see that these two nails are way closer to each other than that one and this one, but you can't split across the grain. You only split with the grain, right? So again, these can't be in line with each other like they are. So what you want is that staggering up and down like that, right? So if you follow these wood grains in here, it might be a little bit hard to see, but you start with that top one, you can see that wood grain comes down, and that's where this one is. So it's a little bit over. How much does it have to be over? There's really nothing in the code that says how much you need to stagger. If you read through the commentary in the SpidWiz, though, it says even as much as an eighth of an inch will prevent that or should prevent that splitting. So, and here's kind of what that looks like out there in the construction. You know, so not everybody I know is going to, you know, put a couple lines on every panel edge of their sheathing. But when they're going through shear wall tests and stuff, they want to make sure that they're doing things correctly. So, you know, they'll put a couple lines on there 1/4 inch apart and make sure that they stagger their nails on the way down. And then here's, you know, when a lot of people say staggering and they see two panels coming together like this, you know, they think, all right, one here, then one there, then one there. But you can go across this way. Like I said, you know, you can't split across the grains on the wood like that. So it's just staggering as you're going up those studs. On something like this, you know, they do have two studs next to each other. You can do that. You can put those nails in on a little bit of an angle if you want to. That's perfectly fine. IBC 230492 sheathing fasteners. So even in the IBC, it has that in there, right? Sheathing nails, other approved sheathing connectors shall be driven so their head or crown is flush with the surface of the sheathing. And then in SpidWiz 4363, sheathing shall be attached to framing members using nails or other approved fasteners. Nails shall be driven with the head of the nail flush with the surface of the sheathing. So assuming the panel is fastened properly to the studs, this is happening at every nail, both on the edge and in the field. So again, make sure they're not overdriving those. We'll actually look at that in a second here, but and I talked before, about, equal and opposite forces, right? So this shear panel, this is the OSB, right? So all that shear from the wind and everything goes into that OSB or plywood and starts pushing that over. So that's getting pushed in one direction. So there's actually a force coming back onto that nail in the opposite direction. And that's how that load gets transferred through there. So you do get strength loss with that. So if all nails are 1/16 of an inch overdriven, they've actually tested that out and there's no loss. So 1/16 of an inch, you're probably okay with that. If less than 20% of the nails are overdriven, no deeper than 1/8 of an inch, no loss. But if more than 20% of the perimeter nails in any are overdriven by a 1/16,
or any nails are overdriven by more than an eighth, additional fasteners are required. Makes sense? Yeah. So, yeah, so if you overdrive any of them by more than an eighth of an inch, they're pretty much not doing anything at that point. I shouldn't say they're not doing anything, but again. And not just, you know, and the reasoning for that, you know, is I guess twofold, right? So you've got, you now, instead of, you know, a 7/16 CLT right here, or on that CLT, OSB, now you've reduced that down to what, you know, less than a 3/8 piece of OSB in there, right? So you're shrinking down that capacity, that OSB or the plywood itself is now much narrower, you know, right in there. Plus, as you can see, you know, now you're getting that water coming in, which can start to rot that out a little bit sooner. You know, anything like that, so.
The third bullet point contradict the first.
That's, I know, as I read that, like, that seems a little bit weird. Okay, so any nails overdriven more than an eighth of an inch, you're good there. If greater than 20% of the perimeter nails are overdriven by 1/16, because, yeah, I think that's supposed to be an eighth on that third bullet point. Yeah, that would make sense. Yeah, so 1/16, you're gonna be fine. Less than 20% at an eighth, you're gonna be good. But yeah, once you get, you know, 20% or more at an eighth of an inch, or any that are beyond an eighth of an inch, that's when you're gonna have problems. All right, anchor bolts, you know, we talked about the panel itself, but we also have to, you know, transfer that load down into the foundation or the footing, or the floor, or down to the next floor down below. So anchor bolts, in the Spidwiz, they do require steel or square steel plate washers. So anchor bolts shall have 3" by 3" by 0.229" square washers. Washers are permitted to have a diagonal slot on them. And then the plate washers are required to be 1/2" from the edge of the bottom plate on the side with the sheathing. So you need within 1/2" of the edge of the sheathing, with the sheathing, I should say. And then standard washers are permitted in some. So that's sort of what that looks like. Again, the side with the sheathing, you've got a 1/2" maximum, so you know that it's a 3 by 3 plate. You know, even if you have a 3.5" a 2 by 4 sill plate on there, you know that you're going to be within that 1/2 inch. But if you do have you know, a 2 by 6 sill plate, you got to make sure that it's within 1/2" of that sheathing. And then, let's see, yeah, foundation bottom plate testing. They've been doing a lot of testing on this stuff, talking about cross grain bending of the sill plates. So, when the sill plate fails, they don't want the sill plate itself to snap like this, right? So that's how that's why you have that larger washer on there. It's a much smaller washer. And so what you actually want to have happen is you want to have that nail basically fail in the side of it instead. And here's some of those testings. In the latest NDS, there's actually a kind of a new check for sheathing, for attaching sheathing on there as well. You now also have to check for head pull through. Because, you know, typically we just check to make sure, you know, see when that nail would fail, when it would snap, or when it would bend too much. But what we were really finding is, you know, you kind of can't see it, but so this nail used to be right there. This nail, I think, got cut off up there. This nail used to be right here. So what we were finding is that, you know, the nail itself wasn't really, you know, failing at all. But the nail head was just pulling through that sheathing, and that sheathing was just kind of pulling itself away. So there are checks for that now as well. So watching about nail head pull through. Let's see, the wood frame construction manual. And I won't really get into. Yeah, we can jump through that. All right, so inflating racking strength, increased
So as you keep coming through here, you get more and more strength here, and that's what, there was that one adjustment factor earlier, if you have that hold down device attached to the inside face of the studs on there. So if you can attach it out here on the outside face, that's where you get the most strength capacity. That's what they're actually looking at in those tables. But if you're on the inside face, it still works, but there's a little adjustment factor in there. All right, and then, yeah, and then shear wall testing, they keep doing a lot more of that all the time, so. All right, so I don't know if that helped or if that was even more confusing to you guys or not, but any questions on any of that stuff? Oh, all right, yes.
So we've got one guy that wants to keep using a combination of OSB on one side of the wall and drywall on the other.
Yeah.
And trying to take credit for both. My understanding is you gotta only get credit for the weaker of the two.
Well, you can, yeah, I mean, it depends on which option you're going with in there, but yeah, basically, you know, I mean, if you're to answer your question, yes. You know, yeah, if you're trying to combine systems in there, yeah, you're gonna be using the weaker of the two. You know, if you could do gypsum and then go over that with the OSB, there's that option in there too. You know, if he wants to do something like that, but yeah, otherwise it's yeah, you don't, until something like that gets tested and design values are generated for it, you're stuck using the kind of the lesser of the two. All right, one last thing I wanted to do with you guys then. Oops.
Double the value.
Yeah, or you're pretty much using. Yeah, you would assume that weaker material is on both sides then essentially. Yep. Yeah, yep, no. All right, Lucas, are you seeing this on there still? All right. So real quick, while we got a few more minutes, I just wanted to run through the website, and sorry, I'm gonna sit because I gotta kind of use the mouse and see what I'm doing down here, but this is the Wood Council's website. I just wanted to walk you guys through some of the resources that are on here. Because, you know, back when I was a code official, I knew some of the stuff that we had on there, but not really everything. So I try to, you know, spend a few minutes just to, you know, walk you guys through, show you what's all in here. So if you haven't been out to the website in a while, it just got redone about a year ago. You scroll down a little bit, we've got calculators and tools. If you can see where my mouse is, we've got learning, we've got still our CDP access voting guide from the 2024 code cycle still on there. And then our FAQs and then some news. Well, I'll click into these in a little bit, but I just want to show you everything that's in here. As we move down, we always have our monthly webinars. Every month we do a free monthly webinar, usually around the third week on a Thursday, something like third Thursday, something like that. But we've been doing significant changes to 2021 AWC. We did that last month, and we've got part 2 coming up again this month. So information on that's always on here. Video case study on mass timber, pathways for states and cities adopting mass timber provisions, some other stuff on wood supply chain, some things like that. And then as you get down here into the bottom, let me get rid of that. You know, a few other options down here of, you know, things about us, careers, calculators, again, standards, FAQs. We do have this account registration. If you haven't signed up for our Code Officials Connection, I would definitely recommend that you do that. You can create an account down there. Basically, you get a one email a month that's you know, information that we see popping up that we want to let different code officials out there, code officials and fire officials know about things popping up. So that's all free. And I think you also get a discount on some of our publications and if you want hard copies of it. Let me scroll all the way back up here to the top. We've got stuff on sustainability, on our standards, our calculators again, our calendar. You can log in and you can create an account up here at the top. And then also, on the far right, there's a search button and then our menu. So if you go into the menu, we've got our resource hub, codes and standards, issues. From the issues here, you can get to that mass timber stuff, learn about our events and e-courses. We've got dozens and dozens of free e-courses that are out there that you can take, and not all of them are approved for DSPS credits, but they are approved for ICC and AIA credits. So if you have a ICC membership or any credentials there, or an AIA member, they're all CEUs for that. And then some information about us down here at the bottom. But I really want to go into the resource hub and the codes and standards up here for you. And again, there's a number of ways to get to it, but let me just click on that. So here's, again, a whole bunch of stuff. I want to go to first one here, or actually the third one that's on here. I'll start with the first. So the first one on here, design standards. So that's where you're going to get your NDS, your FDS, your SPIDWIZ, all that type of stuff is right in there. So if I click on that, again, there's older versions in here as well. Wood frame construction manual, permanent wood foundation guide, all that type of stuff. So again, you can view it all for free. You can download it. Just if you want a hard copy, then we charge you for that. But calculators and tools is the next one over. So we have our span options calculator, an acoustic calculator, connection calculator, energy calculator, and then height and area. Height and area, we're still working on to get that up to the 2021, because there's a bunch of changes in the 2021 on how to calculate height and areas, but for the 2015 that's in there. I'll just jump into the span calculator real quick. And again, this is all free, all out there on the website. Still loading here. All right, so a couple different options here. So you can do max span at the top or span options. So maximum span, you're going to put in, what do you have, floor joists, rafters, whatever, what deflection limit, what spacing do you want, what loads, what type of wood, and it's going to tell you, your maximum span, of course. The span options one, now you can just put in a handful of these things. So maybe you know what type of wood, but maybe you don't know what grade, but you do know your span that you're looking to do. So you can put your span in here at defaults at 12 feet, but you can put in I have this much of a span, but I don't know what what size or what grade of lumber I want to put into here, and it'll spit you out and tell you you can use a 2x10s at 12 inches on center of Doug fir, or you can use 2x12s at 16 inch, whatever it is. It's going to give you your different options on how you can do that. The acoustic calculator that gets into some of those acoustic properties of wood. Doesn't have mass timber in there yet. Connection calculator. So if you run into a weird connection situation out in the field, you can go into there. You know what nails that they're using or what bolt they're using, and it goes into connections with wood to wood. Or sawn lumber to sawn lumber to OSB or plywood, sawn lumber to steel plates. A couple other options in there. So a bunch of different situations that you can, put in different types of connectors, different types of situations, and see how what structural capacity you have on those. That is something that's kind of nice. Then if you run it, you're out in the field, and the engineer had specified round head nails, and you find something else out there, you can kind of see how much value difference are we talking here. All right, so let me back up onto the calculators. Design for code acceptance. This is one of the bigger ones that I wish I knew about. So we have a whole bunch of design for code acceptance. So these aren't things that are in the code, but they're basically the test methods and the procedures on how to design something to be in compliance with the code. All right. So like our DCA one, that's flame spread of wood products. So that's more your finishes. Okay, so it's got a whole bunch of different wood in there, wood types, and what the flame spread and smoke developed ratings are of those different wood materials. The DCA 3, that's our fire resistance rated wall and floor ceiling assemblies. So, everybody's familiar with, UL numbers for, rated walls or things like that. Well, we have our own as well that we've put into there. The things that we do a little bit differently with ours is we just have just generic materials, so we're not product specific on anything. UL, obviously you've got, a certain type of gypsum and a certain type of other products in there. All of ours were tested using generic materials, so nothing's proprietary in there. The other really nice thing with the DCA 3 is that it gets into a whole bunch of different situations where you have fire rated ceiling, floor ceiling assemblies and fire rated exterior walls in wood construction. And how do you deal with that intersection between the two of them? What has to be fire rated? What has to be part within the 2-hour assembly or the 1-hour assembly, whatever you have? What's got to be fire retardant treated wood? What doesn't? So if you run into any, like a 2-hour rated exterior wall and maybe a 1-hour wood floor coming into that, how do you deal with that intersection? And that's all figured in our DCA 3 guide. DCA 4 is calculating and demonstrating assembly fire, that CAM method. So that's in 719, I want to say, in the code, where you can do that additive method for code acceptance for determining fire resistance rated walls. So if you haven't done that before, our DCA 4 kind of walks you through, some common assemblies and how you actually work through adding up those different members. DCA 5 is our post frame building code. Our DCA 6 is our prescriptive wood deck guide, which is very similar to Appendix B in the UDC. And actually, if you look into the commentary of Appendix B in the UDC, it actually says that you can use the DCA 6 as an equivalent. So yeah, you can use that. There's also a Spanish version of DCA 6, our deck guide out there as well. And then DCA 7 is our residential energy requirements for wood frame buildings. Again, walking you through, how do you comply with the code? All right. So those are our design for code acceptance. Next one over here is our technical reports. So again, we talked about that TR10 earlier, but a lot of these are a little bit older and they've been developed into some of the other new standards that we have out there. But again, it does provide a lot of the background information that was put into those standards and those codes. So comparative fire tests of timber and steel beams is our TR3. So, looking at a steel beam, looking at a wood beam, and comparing how they react in fire. The wood frame house is a structural unit is our TR5, TR8 energy conservation studies. Heat release rates for construction assemblies is our TR9. The TR10 again is fire resistance of exposed wood members. General dowel equations for calculating lateral connections. So again, if you have like that we talked earlier about the dowel laminated timbers, and if you're looking at how do you figure lateral loads through doweled connections, that's all in there. TR14 lateral torsional stability in wood members, and TR15 the calculation of sound transmission for wood frame assemblies. So again, a lot of just odd topics, but I like to kind of walk you guys through this stuff just so a couple months down the road, one of these situations pop up and you're like, oh yeah, I think that there's some resources out here. I remember hearing something about that. We've got a bunch of design aids. Span tables are in here as well. So span tables for joists and rafters, the 2021 version of that, and then some older versions as well. So if you do have, older buildings, you can go back I think one of these had, yeah, this goes back to like 1986, I think. And I think somewhere in here, we've got some really old NDS versions as well. So you might be able to go back, look up some of the old versions there. Code conforming wood design. We should be coming out with the 2021 version of this really soon. So right now we're at the 2018 code conforming wood design, but that's basically a commentary document that walks you through everywhere that wood is used in the IBC. It provides a little bit of commentary on where that is and how you apply that to your building. So the code conforming wood design guide is another great document. It also walks through, or it also has a whole bunch of area tables for different wood frame assemblies, so that you don't have to go through calculating out areas or fire separation distances. Once you have those in there, you can kind of go into that table and get some kind of generic language on about where that should be without getting into the specifics of it real quick and easy. Some other design resources, some wood construction data. I haven't even opened up this one before, but let's see what's in here. Conventional wood frame construction, tongue and groove, roof decking, plank and beam frames, heavy timber construction, looks pretty old. And then design of wood frame structurals and permanence. And then there is updates and errata section down here as well. And then our FAQ page. And this is kind of where I'll leave this, but we've got our FAQ page. And again, this comes from code officials and inspectors that are out there. So again, if you guys run into situations, let us know. So, we're adding to this stuff all the time, but we've got stuff on standards, codes, and our standards, regular codes and standards, fire resistance, general materials, supporting documents, sustainability, and then our webinars. But you kind of look through this and you're like, oh, you only have a handful of these on our standards, but there's this load more button down here at the bottom, and that loads a lot more. So we have tons of FAQs out here. Yeah, see, I'm not even halfway through this. So a lot of FAQs. Some of them are a little bit outdated. Sometimes they're talking about, a 2012 version of the NDS or something. That's something I keep telling our people, we need to go through and kind of edit that down a little bit, but it is good though. A lot of great information out there. Like the first one on here, where can I find lumber specific gravity? We actually cut and paste, a lot of the common specific gravities right into that one. But then we also give you some links to where you can find it in the NDS as well. So a lot of great information. So if you are looking for something, here's under general, where can I find technical papers on timber retaining walls? Where can I find information on evaluation, maintenance, and repair of existing structures? And here's some resources on evaluating existing structures. So a lot of great stuff in our FAQs. I'll kind of end it there. If you have a topic that you're interested in or anything like that, and you're not sure if it's on there, again, grab my card, shoot me an email, give me a call. I can maybe narrow some of that down for you, or we also have other resources that we don't put out on our website that I might be able to help you out with. So, all right, I have talked for about 5 hours straight now. So, anybody have any questions on anything we covered today? Anything on mass timber? Anything on other wood construction? Anything like that? Whew. Good. All right. Well, with that, thanks everybody again. For those of you that are in the inspector groups or anything like that, feel free to reach out to me. I'll gladly come around to any of the quadrants, do any training. Hopefully some shorter presentations as well. We have anything from, a half hour out to full day stuff. So, feel free to reach out. I'm free, but again, you get what you pay for, like I warned you this morning. So thanks, everybody.
Thank you.
Everyone out there in the virtual audience, I will get your CEUs uploaded next week. If you need anything from me, feel free to reach out. If not, thanks for attending and have a good night.
Thanks, Ed. Yep, absolutely.